The aurora, also known as the aurora borealis, in the northern hemisphere, or aurora australis, in the southern hemisphere, is a natural light display predominantly seen in polar regions. It occurs when charged particles from the sun interact with Earth's magnetic field and atmosphere, causing ionization and subsequent light emission. Here's a more detailed breakdown. 1. Solar wind and magnetosphere interaction. The sun emits a constant flow of charged particles known as the solar wind. When these particles reach Earth, they interact with Earth's magnetosphere, the region controlled by Earth's magnetic field. Some of these particles are funneled toward the poles by the magnetosphere, where the magnetic field lines converge. As these high-energy particles travel along these lines, they collide with atoms and molecules in the Earth's atmosphere, primarily oxygen and nitrogen. 2. Excitation of atmospheric atoms. The energy from the collisions excites the atoms and molecules in the atmosphere. As they return to their normal state, they release energy in the form of light. This is what we see as the aurora. Oxygen molecules primarily emit green and red colors, depending on the energy level of the collision. Nitrogen molecules produce purples and pinks. 3. Colors of the aurora. Green is the most common color, typically caused by oxygen molecules at altitudes of about 100 kilometers. Red auroras, though rarer, are produced by high-altitude oxygen atoms, often above 200 kilometers. Purple and blue colors come from nitrogen molecules, typically at lower altitudes. The variation in color depends on the type of gas and the altitude at which the particles interact. 4. Magnetic field's role. The Earth's magnetic field plays a central role in shaping auroras. The charged particles from the sun are directed along magnetic field lines toward the poles. The aurora is strongest when solar activity is high, such as during solar storms. Solar storms can increase the intensity and size of the auroras, creating more dramatic and widespread displays. 5. The aurora oval. Auroras tend to appear in a ring or oval shape around the magnetic poles of the Earth, called the auroral oval. This ring is most prominent at high latitudes, near the Arctic and Antarctic regions. 6. Solar cycle influence. The frequency and intensity of auroras are closely tied to the solar cycle, which lasts approximately 11 years. During the solar maximum, the peak of the solar cycle, solar activity increases, leading to more frequent and intense auroras. During the solar minimum, auroras are less frequent and less intense. 7. Auroras and space weather. Space weather, driven by solar activity, can influence auroras. Strong solar flares or coronal mass ejections, CMEs, can lead to more powerful auroras, and can even affect satellite communication, GPS systems, and power grids on Earth. 8. Geographical location. The aurora is most commonly observed in regions close to the magnetic poles.